Good evening, all the participants. First of all, I would like to thank Meadow Agriculture for inviting me and all the organizing partners for inviting me to deliver the lecture in this 21 days winter school. So in this, I will be delivering a lecture on artificial intelligence as a tool for sustainable and precision piggery farming. I'll be discussing in these lectures regarding on pig farming because I am posted in NRC on pig, but this technique can be applicable in other livestock sector also. So the content of my lecture will be, I'll give a brief introduction first, then I will go on what is artificial intelligence. Maybe all the participants might have come across what is artificial intelligence before in a previous lecture also, but let me explain in a very simple way so that this technology can be applied in this livestock sector. Then I'll be discussing on about why talk about AI in piggery. What is the importance of AI? And what is the precision piggery farming? What is the role of artificial intelligence? And for artificial intelligence, we need large data sources. So in piggery farming or in any other livestock sector, what kind of data we have to collect from the farm and we can use and how to apply this artificial intelligence in this kind of data sources. All these things will be discussed in this lecture. So this is the application part. Okay, so artificial intelligence in piggery, in which section we can apply AI technique. This is just a overview. We can apply artificial intelligence is a technique which we can apply in any field if we have data with us. We can apply in nutrition management, environmental monitoring, reproductive and breeding management. Then we can use for farm automation, drought monitoring. Then we can go for pig detection, segmentations. Then even in for health monitoring in the farm environment. So this is the applicable area where AI can be adopted in the piggery sector. First, we know that pig farming is very important in India because nearly 40% of the India livestock GDP is contributed from the piggery sector, and Northeast is the Northeast is the main reason, like Assam, then all the Nagaland, all this part is a main reason where pig farming are mainly adopted. So this is very important, pig farming, and it's a very for not only for livestock production, but it also play a role in food security also, and there is an increasing demand of pork requirement in this in all the nation. So in order to have a higher productivity and efficiency, we need a technology. Without technology, with traditional practices, it is impossible to meet those demand. Then to meet those demands, there are certain challenges coming up, like disease outbreak, then feed cost is rising, the labor shortage is becoming an environmental concern. There is a climate change are occurring. So these are all the challenges which the livestock sectors are facing right now. And we know that currently in traditional management practices, are often labor intensive. We know this because we have to integrate manual labor in that farm to monitor the animal, to provide the feedback and all. So this is like when we want to go for commercial farm, traditional management practice is impossible, I will say this. So in such case, artificial intelligence is a technique which can enable, which can solve such kind of problem, like by adopting smart and data-based decision making in livestock system. And AI also contributes to sustainable, then efficient and welfare-oriented pig production system. So this is a brief introduction, and we will come to know to this discussion about what is artificial intelligence. We know that AI. What is artificial intelligence? It is the simulation of human intelligence. Human intelligence. Human will be developing a machine that can, think, learn and act like exactly like a human. So behind that machine there will be a certain programs, certain programs will be there, so that the machine can capture the data. From that data they can learn something, and according to that historical or past data which they have learned, they will give some informations or some decisions based on the past data. So this is the definition of AI. AI will be learning from the experience data. They will be reasoning. Reasoning is like ability to draw some conclusions from the information which they have learned. Okay, so then perception is to interpret those informations. give some conclusion of those information. So this is the definition of artificial intelligence. When we know about artificial intelligence, there are many confusions, like what is machine learning, what is deep learning. We know machine learning, deep learning, but how it is differed. All these things should be properly and clearly defined. Then only we can, when one problem is there with us, then what kind of technique to apply, that we can decide from our end. So we should know what is AI, then what is machine learning, what is deep learning. So it is a like hierarchy. So artificial intelligence is a broad scope, and then again the machine learning is a subset. Machine learning is a subset of artificial intelligence, and again deep learning is a subset of machine learning. So the difference is that just in the algorithm part and the complexity part and how much data are required, all this differs algorithm to algorithm. So when we come to machine learning, it's a subset of AI that focus on the use of data and develop an algorithm, okay, to imitate the way human learn, gradually improve its accuracy. So this is machine learning. And again, what is deep learning? Okay, so deep learning is a subset of machine learning, which is based on artificial neural networks with multiple layers. As our brain have a number of neurons, like similar to that, artificial neural networks also have a number of multiple layers that attempts to simulate the behavior of human brain to learn from vast amount of data. So for deep learning, vast amount of data is required, but for machine learning, with less amount of data, we can perform certain tasks. So this is the difference. Okay, then why talk about artificial intelligence in pig farming? There are reasons why AI is very much necessary right now in any livestock farming, not only piggery, but in any other livestock farming. So we know that the image also, just see from the image, the traditional farming and the smart farming. In traditional farming, manual, manpower is involved, but in smart farming, everything will be automatic. So in traditional farming, what kind of drawbacks will come? Just see, when manual will be, when manpower will be involved, everything should be maintained by a human being. Okay, but if it comes to a large commercial farm, maintaining a large animal, huge number of animal every day, it's very difficult. So when we want to go for commercial pig farming, smart farming is the is the best solution. Why? India is like having a increasing demand of pork product. So technology should be there in order to meet those demand. Without technology, big commercial farm management is impossible. So these are the reasons. First is like demand of pork, then higher production efficiency should be increased. So for that purpose, artificial intelligence is important. Then feed cost is also rising. So in order to reduce the wastage of feed, so we can use AI. Then again is the disease outbreak and the biosecurity risks. When manpower is involved in the farm environment, the risk of disease outbreak is very high. And biosecurity measures, we can break the biosecurity measures when manpower is involved in the farm environment. So to solve such kind of problem, artificial intelligence, the smart farming technology is necessary. Labor shortage is also another factor, because the cost of manpower is increasing. Then to solve that, we can go with smart farming techniques. And environmental stress. There are certain environmental parameters which directly affect the pig health and the growth performance of the animal. So in that case, artificial intelligence, like sensor device which we can integrate it with AI analytics tool, can use in the farm environment to solve certain kinds of problem. Then another is manual monitoring. First, I have told also that manually monitoring is very time consuming, and it is impossible if the farm is a commercial farm. So for that purpose, AI is very much necessary, and for AI is needed for real-time data-driven decision making, and to fulfill the demand for like sustainable and welfare-oriented livestock system. This is about importance of AI in piggery. Then next is, what is precision piggery farming? Adoption of such kind of technology in pig farming or any livestock farming in order to obtain higher efficiency, productivity, or sustainability is known as the precision pig farming or precision livestock farming. So in precision livestock farming, there are different, tasks which we can carry it out, like individual peak monitoring can be done, the real-time data collection can be done through these sensors and camera-based tracking of animals, their behaviors and all can be done, and automated health and growth assessment also can be done using such kind of techniques, and data-driven farm management. This is the main important which we can carry it out using artificial intelligence technique. So what is the role of artificial intelligence? I will describe each and every, sections, like for health management, how it will be done, for nutrition, then for reproductive management, and any other animal science branches, how this AI can be integrated in such things. Okay. In animal, health management is like, first we have to see about disease. Disease is the main thing which lead to the mortality of the animal. So we have to think that what kind of AI algorithm can be applied so that we can go for disease predictions, or detection of any behavioral abnormal behavioral patterns, so that the monitoring of animal at the right time, or intervention, or giving of some treatments or medicine at the right time can be carried out. So for this, what we can do is, like, we can use an image. Okay, image data can be used, like installing some CCTV camera and all. I will later on show the image, how the data can be analyzed. So image data can be used to analyze the lameness and lesion detection, and AI-driven health alerts and treatment recommendation also can be done. And I have also told that abnormality detections through movement, because we don't know, no, animal cannot speak. So we have to see the behavior, the abnormal behavior, the normal behavior, what is the difference. According to the behavior, we have to analyze that whether they are healthy or not healthy. And these techniques will lead to the reduction of mortality through predictive modeling. This is about health management. And when we come about nutrition and feeding management, like feed intake monitoring is very important. Okay, because how much per day, how much this per animal is consuming the feed. This is very important in order to identify whether the animal is healthy, or whether animal is having any illness, or is it normal. To identify that, feed intake monitoring is very important, because animal will not take feed when they are ill. So in such case, feed intake monitoring is very important. And precision feed allocation is like automatic feeders, which there is a sensor will be there. When animal comes nearby, the amount of certain amount of feed will be released from the feeder, so that the wastage of feed will be avoided. So this is the applications of AI in nutrition and feeding management. Next, come to the reproductive management. When we come to reproduction management, it's like estrogen detection, like heat detection at the right time. For that, we have to see the behavior of the animal. The behavior of the animal will be different from the normal behavior. So farrowing predictions model, we can develop this. Then improve breeding efficiency, then reproductive performance monitoring. So this is about health, nutrition, and reproduction, in which area we can apply artificial intelligence. Next is about animal monitoring and analysis. Animal monitoring and analysis is the main thing which covers everything. I will say this because when we monitor animal, we will go for health also, we will go for nutrition also, we will go for reproduction also. So animal monitoring and analysis is very important. Individual animal can be monitored, it can be tracked, how much time they have slept today, how much time they visited the feeding area, how much time they are in standing or walking or sitting, or whether they are active or not active. All these things can be monitored, okay, in real time, and we can analyze those data. Then we can see which animal is not performing better, which animal is not normally, the activity pattern we can recognize from that. The stress and aggressive detection also can be done. The next comes to the environmental and housing management. When we come to the environmental and housing management, it's like, we know in livestock farm, the animal waste, from that animal waste, there are many harmful gases used to get released, and it used to have so many toxic gases like ammonia, carbon dioxide used to get released. These gases used to have direct impact on the animal health and the growth performance. So we need to monitor the temperature, the humidity, the ammonia, carbon dioxide, and many other harmful gases which has been released from the wastage of the animal. So when we monitor these, we can develop an AI algorithm so that this monitoring level, the threshold level can be maintained, and when it exceeds the threshold level, an alert system can be given so that the farm manager can take an immediate actions at the right time. So this is about environmental monitoring. And next is about growth and physiological monitoring. We know now that peak weighing of live weight of animal is very difficult because it used to involve so much of manpower. Like for pig, it used to take around 4 to 5 manpower. People should be after the pig to wait, to take the measurement of that pig. So it is very difficult. In such case, AI can, contribute by like non-contact weight estimation using computer vision, like image-based or video-based. All these things can be developed. From that, also we can study the growth curve prediction model can be developed. We can go for real-time body condition assessment, and continuously like physiological status monitoring can be done using artificial intelligence. So this is about the data sources, like artificial intelligence data sources in pig farming. Like we can use RGB cameras, normal CCTV cameras, we can use RGB thermal cameras, we can be used. Then IoT environment with sensors, like all the sensor device for different environmental gases monitoring can be installed in the farm environment. Then we can use RFID tags in order to track, for tracking of individual pigs. Then other we can use like weather and climate, then weighing, then genomic and phenomic data also can be done. Then what is the activity pattern of the pig? Then acoustic monitoring, like from the sound data also we can analyze whether the pig is healthy or not healthy. So these are all the data sources for pig farming. So all this device can be installed in the farm environment, and we can collect the data continuously. And those data, once if the data is there with us, we can decide what kind of problems are occurring in the farm, then how can we solve this problem. Then using those data we can develop some models, then we can develop software integrating those models. All these things can be done. So main important with artificial intelligence is data should be with us. Then after that we have to define the problems. Next is, I'll just give the example, okay, how the monitoring is done, how the data looks like, what kind of algorithm is there. When algorithm is there with us, then how the results used to obtain. So this is about animal monitoring and analysis. Cameras, sensors, and all these things can be installed in the pig pen to captures the image, video, activity pattern, then postures. And computer visions and deep learning algorithms can be used to detect and track this individual pig without physical contact. See, in the figure we can see that all the devices are installed in the pig farm, and next after installing they collected the video, and those video they have done the annotations of those video. From that annotated file they have developed some algorithm, and from algorithm they have done the segmentations, and they have done the identification, detection of what kind of behavior the animal is performing. And the last D and E figure is the segmentation of the objects, that is the pig. So this is how the animal monitoring and analysis can be done using artificial intelligence. And in behavioral states, now we can go for analysis of standing, lying, eating, and different types of behaviors based on the animal. So we can do this. Then machine learning classifier, we can go for deep learning also. So we can develop such kind of algorithm to identify the patterns, to identify healthy status and abnormal behavior. And this data, this model after developing, we can integrate it into a software, and a dashboard can be developed, so that through dashboard everything will be seen, like per animal how many what is the trajectory of this animal for 24 hours. All these things can be seen through the dashboard. So this is animal monitoring and analysis. And this is about the tracking and monitoring of individual pig behaviors. See, these are all the video frames. Okay, these are all the video frames, all the figures are there, and in that they are tracking each and individual animals through RFID systems. So this is how the data recording systems, for each for identification of behavioral are done in the farm environment. And this is the detections of without behavior and with behavior. First is without behavior, means like detection of pig only. This is first is only identification of pig. Then next is with behavior, whether they are lying, whether they are standing, or whether they are sitting, all these things, and whether they are in eating, all these things can be identified. And this is work which we carried out in NRC on pig, and this is our farm environment. We collected the data from our farm. Then we collected a video data from our farm. Then through the video, we segment segment into frame, extracted into frame, and in that frame we have done the annotation part. And after annotation, we develop a model. Okay, we have done analysis of different deep learning models, and then through that models we have done the extractions, like the segmentation, the detection, and even the classification. I'll show you the results. This is the result. See, the bounding box is the detection, then the lateral lying and all. This is the the classifications, whether it is a lying or whether it's a working or all these things. Okay, then the percentage, how much accuracy is given. Sometimes it's 100%, in some pig it is 98%, in some pig it is 89 and 83%. So this is the work which we have done in ICAR NRC on pig. So regarding health and welfare, we can go with different, like we can go with either monitoring of all the farm, or we can go by analyzing the sound data, because when animal are not feeling well, or if they are suffering from certain diseases, the sound of the animal will be different. So we can install certain microphones in the farm environment. Those microphones will be collecting the sound of each and every pig, and continuously the sound can be recorded for 24/7, and all the data will be collected. And once the data is there, from that data, what kind of sound we have to consider, is like whether it's a coughing, whether it's a sneezing, whether it's a labor breathing, or whether it's a wheezing, or it's a distress vocalization. All this type of sounds can be analyzed from that. And even for supporting data, like based on the environment also, like based on the environmental factors like temperature, humidity, ammonia and all, the sound will be different types of sound can be released. So we have to consider that environmental parameters also. So this is about the sound. And next, how this data will be analyzed, I will explain in the next slide. So the first step is like we have to convert those raw audio sound into a digital signal. From that, we have to remove the noise, the background sound removal, and conversion into a spectrogram. And once this conversion is done, we have to extract the features from those data, like frequency pattern, the amplitude variation, the curve duration, then repetition rate, acoustic energy level. All these things are the features. Once the feature is extracted, we can use we can develop a machine learning or deep learning model, and these features will be, the extracted features will be given input in this model, and a pattern will be recognized. And cough or normal or abnormal vocalization can be identified, and early detection of respiratory disease or any other health issue can be done. Next is about, from that, what kind of welfare will be provided. First is, it will increase the cough index annotation. Like automated alerts will be there, so that we can we can integrate, we can take the precautions at the right time, and early warning of respiratory disease can be done. Then it also provides welfare and production benefits, like early treatment reduces mortality, lower antibiotic uses, improved growth performance, and continuous non-invasive monitoring can be done. So the veterinary, and that is about the welfare. Next is about the veterinary importance. So objective is like respiratory health scoring can be done, then disease outbreak prediction can be done. So, and data-driven intervention strategies can also be done. So this is the welfare which can be provided from such kind of technologies. Next is about the body weight. Okay, the prediction of body weight. I have also told before that body weight in livestock is very important. It depicts many things. When body weight is not gaining, that shows that pig is having some issue. like some illness or something is not right with the animal. So pig weight is very important. In order to identify the pig weight, there are two techniques. Either you can go from manual data, which normally a pig farm, in every pig farm there is a data record keeping is there. So in every data record keeping, all the daily feed intake, the duration per visit, the frequency of feeder visit or feeding weight and body age and previous weight record will be maintained in that record book. So using that data also, we can develop a prediction model for like pigs or any other livestock. So once after, if we have the data sources, we can take that data, we can go for data pre-processing and normalization. From that data, feature extraction can be done. Then algorithm like linear regression, random forest, support vector machine, then artificial neural networks, all these things can be developed. We can train that model. Validation of the model can be done from the historical data sets. And from this model, we can get an output like body weight, how much body weight it is. Predicted body weight can be obtained. The growth curve forecasting can be done, and detection of growth deviation or health issue can be obtained from such kind of model. Then next is about using of some other kind of data, not that historical data, then not that record keeping data. We can use image data, RGB camera data, like CCTV camera or 3D camera data, like kinetic imaging system we can use, infrared data we can use, all such kind of data we can use, like through image or through video. So this can be installed in the farm environment, and it will be continuously capturing the animal video without human intervention. And those data we can extract from the storage device, and those data can be pre-processed. After pre-processing, feature extraction can be done, and after feature extraction we can go for development of certain object detection models like RCNN, YOLO, SSD models. And in that image also we can apply for certain image segmentation, that's for identifying the body dimension like body weight, herd guild, body area, and SAP features. So after extracting all this, we can fit these extracted features into artificial neural networks, and we can develop the algorithms and train the models using actual weight data, and database stores learn all the patterns from that features. Okay. After that, validation and output will be done. In output, what we will get is the estimated body weight, the growth curve monitoring, and early detection of abnormal growth can be monitored easily without any human intervention in the farm environment. So this is the advantage of AI in big growth prediction. Next, about nutrition and feeding management, as I have also told before, like we can install a sensor where it can detect sensor with camera where it can detect the growth of the pig. Based on the growth, the required quantity of feed can be released from the automatic feeder machine, and only that amount of feed can be consumed by the animal, so that it will lead to the reduction of feed wastage and operational costs. So this is the main area where we can apply artificial intelligence in nutrition and feeding management. Okay, so in developing those models, we can use different type of machine learning, we can use other deep learning techniques also. But when we go with feeding, and when we go with feeding, when we go with monitoring the weight and everything, we should also take care of environmental parameters. So this is about reproductive management. Infrared or thermal imaging is the only means where we can detect stress detection at the right time, because we sometimes used to miss when we monitor the farm, heat detection, if it is not properly detected at the right time, reproductive for giving an artificial insemination and all, this should be monitored at the right time. So sometimes when manpower used to monitor the animal, we sometimes miss the heat of the animal at proper time. So manual observation is subjective, and it is also labor intensive. In while using thermal imaging, we have to monitor the temperature of the body surface temperature of the animal. So if there is a heat, if the animal is having heat, then the body temperature will be fluctuating from the like in comparison with the normal body temperature. So in that case, we have to monitor and we have to keep tracking. Then we have to see if there is any fluctuation. We have to see whether the animal is in heat, or is there any other body, abnormalities or body swelling or something where the temperature is increasing. So thermal imaging is the only solution which we can use for reproductive predictions or detections or something like that. For like in data collection, I have said infrared thermal cameras will be installed in the soap pen, and continuous automatic image will be captured, and RFID for individual animal tracking can be done. Then environmental data, even temperature and humidity, because due to temperature and humidity also, sometimes the temperature of the body temperature of the animal used to get increased also. So we should monitor all this environmental as well as the body temperature. Then next is the step, how we have to do. We have to capture those image. We have to analyze, pre-process those image to remove the noise reduction, filtering, everything, identify the reason of interest. Then temperature feature extraction can be done. Then we can use deep learning classification like CNN models for automated, stress detection. Okay. Then final output will be the real-time heat alert to the farm manager can be provided. So we can develop a dashboard so that a farm manager need not go to the farm, inside the farm, and see what is happening in the farm, but he can monitor from distance also that what is happening in the farm, what kind of alert systems are coming. All these things can be monitored. So the benefits, what is the benefit? Main benefit is that it will improve the reproductive performance. Then early farrowing management can be done. Then economic impact, it will lead to the economic impact also. Then a veterinary relevance, all those, the decision making, the right time decision making can be done easily. Next is about environmental and housing management. So in environment, I have also mentioned before that the air quality used to get deterioration because of the waste released from the animal. So from that waste, the ammonia, then carbon dioxide, all these things used to directly impact the growth performance of the animal. And temperature stress lowers the feed intake, and poor housing increase the disease incidences can also be increased. So we have to, like, there are certain key parameters in farm environment which we need to be monitored, like ammonia, carbon dioxide, hydrogen sulfide, temperature, humidity, the air velocity, and ventilation breadth. So for this purpose, we can use sensor. We can install some sensors like which can detect a gases sensor. Then the infrared carbon dioxide sensors can be installed. Then digital temperature, humidity, detection can be installed. Then after installing all the sensors, we can develop an IoT network environment where all the sensors will be integrated and can store the data. So once the data is stored, we can extract those data. Then we can, analyze those data to identify the abnormal gas rest and predict the heat stress, the condition in advance, or identify harmful environment patterns. So from this, it leads to the automated control measurements. We can activate the ventilation fans and adjust the air inlet, outlet, and trigger the cooling or heating system and send alerts to the farm manager. So this kind of mechanism we can adopt in any livestock sector. So this is some of the implementation guidance for the beginner. See, deep learning, artificial intelligence is not only area for computer science people. This is a technique which any people can apply. Anyone can apply. Whether someone is working in animal physiology, whether anyone is working in animal, genetics, or whether he or she is working in animal biotechnologies or any other field. Out of veterinary also, in any other field, they can apply this artificial intelligence. And nowadays everyone are using this. It's not that difficult. It's very easy. It's very easy, but we don't need to learn from A, B, C, D, E, F, but we should know what kind of tools can be used. What in this tool, what kind of work we have to do. All this, only that much you have to know. So this is a guidance. First is like we should know what kind of problem we are having, identify the problem. After identifying the problem, there are two conditions. If you want to go for machine learning, then you can go with your i5 processor or i7 processor or simple 8 GB RAM or 16 GB RAM. But if you want to go for deep learning, GPU is necessary. that is a graphics processing unit. Okay, that is necessary. That if you cannot purchase the system will cost around like minimum like 4 lakhs, 4 lakhs to 4 to 5 lakhs. That is the minimum cost. So for GPU, if you want to develop a deep learning model, it's not necessary that you have to purchase that 4 to 5 lakhs GPU. You can work with your Gmail account, because in Gmail there is a platform called Google Colab. There they used to give a free GPU for 3 hours, and if you want to go for higher, you can pay 1,100 or 1,200 something amount. Then you can use Google Colab Pro. That it will support for 9 to 10 hours. But for free, it will support for per day 3 hours. So this is the facility for developing, the platform for using GPU. So I have explained about Google Colab. Next, Python. There are many programming language for developing this. There is a MATLAB, there is R, there is a Python. Okay, but for deep learning, we can go with Python because there are many libraries already. So it's easy for us to develop in Python. For MATLAB, you have to purchase the software that is not open source, but Python is an open source. So you can develop, you can download easily and install, and you can use it. So for Python, if you want to go for Python, either you download the Python or either you download Anaconda. Anaconda is a platform where you can write Python code and you can run. So you can download Anaconda. So these are the two platforms. Next is, if the platform is ready, if the language is ready, when you go about Python, there are many libraries like NumPy, Pandas, Matplotlib, etc. So just go and search in Google, what is this? What is the purpose of this? That's it. It's very simple. Then after that, what kind of data you have? First, go with the data. Okay, you have to go for certain annotations or something with the data. Pre-processing is needed with the data. So when you have the problem, when you define the problem, and when you have the data with you, then you can identify what kind of problem you have to solve. Then you see whether data annotation is required or whether I can directly use after pre-processing those data. This can be done. So there, for data annotation, if you want to go, there are two free open source. There is RoboFlow and Level IMG. So these are the two platform where we can go for free image annotations. Next is, when you want to go for deep learning, you should know what is TensorFlow, what is PyTorch, how to import those module. These are the module of deep learning, how to import this module. If you know how to import, it's easy. You can search in Google. It's very easy how to import this for developing deep learning. So many solutions will be there. Then OpenCV is for image processing and computer vision tasks, and TensorBot is for visualization of what kind of results are coming. All these things can be visualized using TensorBot, and what is the training training rate. All these things can be seen through TensorBot. And second is the last second is GitHub. When you don't know about programming language, anything, when you don't know how to write a Python code, okay, simple. GitHub is having so many sample code with them. Okay, so you can go to GitHub, see the code. What is this code? What this code is doing? All these things you can open the GitHub account and just see what kind of code it is. When you see each and every code, you will feel like you know something about that. So start learning from there. Okay, start learning from the basic small code you run, and you will come to, like, one day you will become an expert coder. Next, go to Kaggle notebook also, for you can get sample data set, already annotated data set and all you can get from Kaggle notebook. So this is a guidance. This is just a guidance from where you will get how to start writing code, and how you have to start analyzing your own data. So this is about the guidance. Thank you so much. If there is any other questions, just let me know.